So at this point, you should have the top half of your notes done. And you should notice that since this function is opening down, it has a maximum. If we're opening up, it would have a minimum. So we'll look at both cases later in the notes. Just to review what we just did in class, where is the ground? We're going to consider the ground the x-axis. That's where y is equal to 0. What is the highest point of the ball? Or what is the highest point the ball will reach? That will be 14 feet because that is the y value of your maximum. And is the path of the ball symmetric? That answer is yes. So if you drew your line of symmetry or your axis of symmetry at x equals 3, you're going to have a vertical line going through the x-axis where x is equal to 3. And if you look to the left of that line and then to the right, you'll notice that the points are equal distance from your axis of symmetry. So yes, this is symmetric. So every function that you guys encounter in Algebra 2 will have a parent function. If you remember from absolute value, the absolute value's parent function was y equals absolute value of x. For quadratic functions, the parent function is y equals x squared. So you can go to y equals in your calculator and graph it, and then also go to the table to get the specific points. So go ahead and do that. And your graph should look like the one we have here. Yours probably looks even a little better. The y values, hopefully you'll notice a pattern with quadratics. If you look at the y values, let's start at where y is 9, then it goes to 4, then it goes to 1, then it goes to 0. After 0, it then goes to 1, 4, and 9. So hopefully you notice that the y values on this function are decreasing, then they hit the minimum point, and then they begin to increase again. Okay? So it had the opposite effect on our first example. This time it's opening up, so the vertex is going to be called a minimum. And that is the parent quadratic function y equals x squared. So for
Mr. Juan Jones, please come to the main office. Mr. Juan Jones, please dial extension 3904. Mr. Juan Jones, please dial extension 3904. Thank you.
all right. So hope you guys enjoyed the interruption. This says, how do you graph quadratic functions using transformations? So if you think back to absolute value, remember we learned about A, H, and K. Again, HK is going to be the vertex. So if something's in vertex form, like our examples are here, like number 1 and 2, those two functions are in vertex form. And from vertex form, you can identify the vertex, which we just learned about. So the vertex for this function is going to be the point -2, -3. Remember, H is the one that you take the opposite of what you see. K you take for what it is. So here's where your H is, here's where your K is. The vertex will be -2, -3. So that's why we use vertex form. It helps us identify the vertex. There's also standard form, which we'll talk about also, and we've used it before. But right now we're talking about vertex form. So the transformations are also very similar to absolute value. Remember that A, depending on what the value is, can cause the function to stretch, compress, or reflect. H is responsible for moving left or right, or we should say shifting left or right, and K is responsible for shifting points up or down. So you guys can go to y equals in your calculator and type this in. Make sure you use parentheses where you're supposed to. We're going to graph y equals x plus 2 squared minus 3. And then go to the table and find the points, and it should look like this. Not quite, sorry. So it's Halloween today. The computers drive me crazy. Sorry, I'll pause it and... All right, so it should look like this. I left the vertex there in red. Ask yourself, is this vertex a maximum or a minimum? If you said minimum, you're correct because it has a low point, right? It goes up forever though. So we'll keep that in mind also when we're talking about some of this other stuff. The axis of symmetry for this graph, remember the axis of symmetry is the line that goes right through your vertex. So I'm going to draw a dotted line here in red. And you see how it goes right through the vertex and makes it symmetric. So your axis of symmetry is always going to be x equals, since it's a vertical line, x equals whatever the x value of your vertex is. So the x value of our vertex here is -2. So the axis of symmetry's equation is x equals -2. Okay? Now, we've done domain and range before with absolute values and linear functions. Well, we're going to do it with quadratics also. So let's talk about the domain first, our list of x values. If you have an arrow going left and an arrow going right, we can say that our domain is going to be from -infinity to +infinity. You always list domain and range from least to greatest. You can't get any lower than -infinity or any higher than +infinity, can you? So this domain includes all real numbers. All right. The range of this, however, is where you look at the y values, right? So range, we're talking about the y values. So now we're focused on the y-axis here, okay? You don't have to draw anything there, but this is what we're focused on. And we're going to look at where the y values begin. So start going from down to up, and let's look at where like y is -5, for instance. Does it match up with that quadratic function, that parabola? No. How about where y is -4? Nope. But look at where y is -3. That's where it begins, okay? So the y values begin at -3, and they include the value -3. So it gets a bracket, and they go all the way up to +infinity. So both arrows are going up towards +infinity. So your range is going to be from -3 to +infinity. Now these increasing and decreasing intervals are always a joy. They are just relying on you to make observations of this function. So we look at it from left to right and decide whether it's increasing or decreasing. So let's start at the furthest to the left, well, as far as we can see at least. And we have a left arrow here. And then start going to the right. What is this function doing? It's decreasing, right? So we'll do the decreasing interval first for this. We always make it in reference to the x values, okay? It goes as far left as -infinity, so that's where it begins decreasing, at -infinity. Well, what is the x value where it stops decreasing? That's right here at your minimum. What is the x value of your minimum? It's -2, right? So our decreasing interval is from -infinity to -2. Those always get parentheses, these intervals, okay? So where is it increasing from? Once you've established the decreasing interval, the increasing interval is pretty easy. The increasing interval, if it stops decreasing where x is -2, then it begins increasing where x is -2. So the increasing interval is going to be from -2, and then this function, as far right as you go from there, you keep going to the right, it's going to be increasing, isn't it? So it increases for the remainder of the function. So it increases from -2 to +infinity. And that's how you would write it. Okay? Now, in behavior is another instance where you're making an observation of something. We always write this part for in behavior as x approaches, so we use this arrow for the word approaches. And first we're going to look to the left, which is towards negative infinity. So as x approaches negative infinity, we then look to see what the y values, which are also called f of x, we say f of x approaches what? So is your left arrow going up or down? It's going up, isn't it? We said it right there. So our left arrow is going up, so we're going to say positive infinity. Move this over here. As x approaches negative infinity, f of x approaches positive infinity. All right? And then the second line is going to say as x approaches positive infinity. So now we're just looking to the right? Correct? So as x approaches positive infinity, with regards to the x, the right side would be going towards positive infinity. What is f of x doing? So what are the y values doing on the right side? What is that right arrow doing? Is it going up or down? It's also going up, isn't it? So f of x is also approaching positive infinity. All right? So the part that I wrote in green is always going to be the pretty much what you're going to write for any in behavior. The parts that I wrote in black are going to change from graph to graph. Actually, just the ones that come after f of x. Okay, so it's not as hard as it appears. The more practice you guys do, the better you'll get at it. And you know, you guys work hard, so it shouldn't be a problem at all. We're going to graph the rest of these on our own, and we'll come around and help you out with them. But keep up the good work, and raise your hand if you have any questions, okay? Good job.